Good morning, guys. It's Miss Fulton. Yay, we're getting ready for final. I'm providing you with a sample of each of the test questions. We'll start out with a simple, y'all know what this is. It is a pediatric dosing. So we have gentamicin 45 milligrams IV Q8 hours for a child that weighs 45 pounds. Recommended dosage is 6 to 7.5 milligrams per kilogram a day in 3 divided doses. So the first thing we want to do is convert the infant's weight to kilograms, correct? So we divide by 2.2, which gives us 20.45. We'll round that to, remember, the tenths place, so we get 20.5 kilograms. The minimum dosage rate, we'll take the weight, 20.5, times the low dose, which is 6. That calculates to 123 milligrams. The maximum, same thing, the weight, 20.5 kilograms times 7.5 milligrams. That gives us 153.75 milligrams. Is the order safe? We'll look here. The ordered dose is 45 milligrams every 8 hours. So every 8 hours is how many times a day? It's 3 times a day. So you multiply the 45 times 3, we get 135. Ooh, is it safe? It is safe. How do we know it's safe? It's within that range. The low is 123, the high is 153. So this is a safe dose. Next, we have albuterol. Do note the problems are going to be pretty similar, even the same labels, but these numbers may have changed, so please pay attention. We've got 1.4 milligrams by mouth 3 times a day, 22 pounds. Recommended dose is 0.5 milligrams to 1 milligram per kilogram in a 24-hour period. What is the infant's weight? Calculate the 22 divided by 2.2 gives us 10 milligrams. What is the minimum dose range? You calculate the 10 times the 0.5, which gives us 5 milligrams. Then what is the maximum? The 10 times 1, 10 kilograms times 1 milligram, it gives us 10. Then we calculate it, get 1.4 milligrams TID, that's 3 times a day. So 1.4 times 3 gives us 4.2, and it is too low, so it is unsafe. It's not safe. I will take not safe or unsafe. Either one, they're synonymous. Next one, same thing. Going to calculate what? The weight of the child or the adult. Same thing, divide the weight by 2.2. That gives us 79.5 kilograms. What is the minimum dose? The 79.5 times the low dose, which gives us 7,950. Then we do the high dose times 200. That gives us 15,900 milligrams. Is the order dose safe if the maximum dose within 24 hours is 20 grams? Y'all don't get confused. We've already done the math, so you don't have to figure out. It doesn't even give you an option of what the provider ordered per whatever milligrams per 8 times a day or 3 times a day. We've done that here for you. So this is what the maximum they could get depending on the order physician wrote. So the thing here, you just have to convert the 20 grams into milligrams. We have to compare apples to apples or oranges to oranges. So if this, your dosage is in milligrams, we have to convert the ordered dose to milligrams as well. So to do that, to convert milligrams to grams to milligrams, you simply multiply by 1,000 and move the decimal. How many places? 3 places. So that's 20 times 1,000 or 20, moving the decimal 3 places using the King Henry died by drinking chocolate milk. So 20,000 milligrams is too high, so it is unsafe. Same thing here. We're going to take the math. We calculate the weight. We have it in 100 pounds. That divided by 2.2 gives us 45.5 kilograms. So we take the low range, 45.5 kilograms, and multiply it by 150 milligrams. That gives us 6,825 milligrams for the low dose. High dose is the weight again, 4.5 kilograms times the high dosage range. That gives us 9,100 milligrams. When you look at this, 10 grams again, what do we do? Same process. To convert grams to milligrams. We move the decimal 3 places to the right or multiply by 1,000. So that gives us 10,000 milligrams. It is too high, so it is unsafe. Next problem. If you'll notice, I have directions here. Determine the normal dosage range to the nearest tenth. So pay attention to your instructions. A child weighing 20 kilograms, already in kilograms, is to receive a medication IV. What with a dosage of 100 to 200 milligrams per kilogram a day. The maximum is 3,000 milligrams. First question, determine whether the dose order is within the normal limits. So how to do that? The low, we know the weight is 20 kilograms. It's already in kilograms. You do not need to convert. So 20 times 100 times the low gives us 2,000. And then we look at the next one. 20 times 200 gives us 4,000. So is the dosage of 3,000 within that range? Yes, it is. What would you do? You would administer medication in this situation. Next one, direction, calculate the child's dosage rounding to the nearest tenth place. So we're going to use DHQ. Don't get confused. It's still we have desired, we have our have, and we have our quantity. So desired is 50. Our have or available is 75. And then our quantity, our Q, is 2. So 50 divided by 75 times 2 gives us 1.3 milliliters. And it does say to the 10th place. Unfortunately, that's where we stop. Directions, calculate the following children's dosage, but still it's underneath the umbrella. I want you to round it to the what place? To the 10th place. So 180 is our desired. Now this is a little different because this says 250 milligrams, but it's a vial. So if it's a vial, there's liquid. So there should be some milliliters. So look on this label, and right here, you'll see it says 125 milligrams per milliliter. It says you would add 2 milliliters of fluid, but once you do that, your concentration or your available is 125 milligrams per meal. So my desired is 180, my available is 125, my quantity is 1. So divide 180 by 125 and multiply, that gives us 1.4 milliliters. The physician has prescribed 20 milligrams of amoxicillin orally every 12 hours for a child weighing 10 kilograms. The safe dose is 0.05 to 2 milligrams per kilogram. Is this dose safe? Same thing. We've got our weight already in kilograms, so 10 times the low, 0.5, gives us 5, 10 times the high, 2 gives us 20. You look at what's been ordered. The order from the physician is 20 milligrams every 12 hours. So in a day, 24 hours, that would be 2 doses. 20 times 2 gives 40. That is too high. It is unsafe. 22, the physician has prescribed Keflex, 25 milligrams per kilogram every 12 hours. For a child, you have your weight. The first dose of medication is given at 6 o'clock a.m., 0600. Look at the question. When should the nurse administer the next dose? It is not asking you to work this out. It is asking when the next dose is due. Because it's every 12 hours, it will be due 12 hours later at 1800. The surgeon prescribing Phenergan 1 milligram per kilogram of body weight. The child weighs 44 pounds. How many milligrams of medication should the child receive as one-time dose? How do you figure this? Same process. They're saying we're going to give 1 milligram per kilogram. So we got to figure out the weight, take the 44, convert it to kilograms. You're going to divide by 2.2. That ends up being 20 kilograms. So 20 kilograms, the child gets 1 milligram per kilogram. So 20 kilograms times 1 equals 20 milligrams. If this was 3, 4, whatever number it would be, you would just simply multiply that to get the dosage. Next, here's what y'all love, the volume over time in minutes times GGT. Just use the whole formula. And that, I think that'll help you. And remember, we've got to do it in minutes. if it's already in minutes, we don't have to do conversion. If it's in hours, then we have to convert it. The pediatrician has prescribed ampicillin, 250 milligrams in 30 milliliters of D5 1/4 normal saline to infuse over 30 minutes. The drop factor is 60. What is the infusion rate in milliliters an hour? So we know our volume. We look for liquid. Liquid is 30 milliliters is what's been ordered. So 30 is our volume. 30 minutes is our time. It's already in minutes, so we don't have to do anything here. So 30 divided by 30, and our GTTs, our drip factor, is 60. So 30 divided by 30 equals 1 times 60 equals 60 milliliters. Let's look at this one. A child has been prescribed Dilantin, 25 milligrams per 2 meals. How many meals of medication will the child receive in a 24-hour period? We need to look at this. So our desired is 25. And actually, we don't even need to do all that math. And we need to transfer it, though. If we're going to do 25 milligrams, they're going to get 2 doses, so they need 50 milligrams. So now desired is 50 milligrams. So our desired is 50. Our available is 25 times 2. So 50 divided by 25 is 2 times 2 equals 4 milliliters is how much they will get, because it's asking what they will receive in 24-hour period. So the next problem is the physician prescribed Solu-Medrol 20 milligrams by slow IV push for an asthmatic child. Solu-Medrol is available at 40 milligrams per 1 meal. The nurse should administer how many? It says milligrams of medication over 3 minutes. It's not asking milliliters, it is asking milligrams. And a slow push, really, to administer that medication, they're just saying how long. All they're asking is how much you're going to give. They prescribe 20 milligrams, so you're going to give 20 milligrams. It's not asking for milliliters, it asks how much medication you're going to give. Heparin. Here's, this is desired over half, because my desire is 400 units an hour has been prescribed. My available is 25,000 units, and it is in the quantity 250 milliliters. So I have 400 units desired over 25,000 units available times my quantity, which is 250. So my answer is 4 meals. Lasix. Let's look at what they're asking. This one, there are a few steps. It's the same math, but it's pushing you a little bit further. So it's asking Lasix 2,000 milligrams in 200 milliliters of normal saline, and 1 milligram per minute has been prescribed. How many milliliters an hour is the patient going to get? So first, we've got to convert this to hours. So 1 milligram per minute, but we know we run the pump in what? Hours. So 1 milligram per minute, we have to multiply by 60 minutes. So that's going to get, for an hour, we're going to give 60 milligrams. 60 milligrams, you can do that, and then you take that and set up the problem as usual. It becomes a DHQ problem. You do 60 divided by 2,000 milligrams times your quantity, which is 200 milliliters, which gives us 6 milliliters.